Saxon's Trig, lesson 120, is about matrix algebra and finding the inverse matrice. The first part, the matrix algebra, is trying to walk you through a series of what kind of seems like random parts, and then they pull it all together. So we remember that when we are multiplying matrices together, we're doing row times column in order to get the answer. So row times column, there's only one column, would give us 4x plus y, and for the other one, it would give us 11x plus 3y. So this, if you recall, if you were I'm going to do this out of order because they're so random. This xy is going to be what they call a coefficient matrix because it will not have any letters in it. Ultimately, it is the answer to the problem, what x and y are. So if you were figuring out what the x and the y was, and we turned this into equations that looked like 4x plus y equals 7 and 11x plus 3y equals 20, the 4, the 11, the 1, and the 3, that's this matrix, is multiplying by something, and we turned it into this pattern. So now this pattern would be equaling 7 and 20. So I could stop and solve it algebraically, 4x plus y equals 7 and 11x plus 3y equals 20, but we're trying to do this in the matrix solution rather than substitution or elimination. So it's coming from equations like you're used to seeing. It's being turned into this. This is being multiplied by something, which gives it the pattern, and now we have the equal 7 over 20. So we can substitute this as equaling 7 over 20. Now before they finish that, they pause and they say, okay, when you're doing algebra and you've got 4x plus 12, you divide by 4 and you get x equals 3. When you're when you have something like, where's their fraction one? Yes, they're saying that, that this accomplishes the same thing when you divide by 4 as if you multiplied by 1/4. And if you do that to one side, you do that to the other side. And 1/4 times 4 is 1, and 12 times 1/4 is 3. So the same thing is going to happen here in the matrix information as is happening algebraically. So the identity for multiplication is what says, what do I multiply something by that does not change its value? Well, we multiply it by 1. So in the matrix information, I need something that is equivalent to a 1 value that I can multiply by without changing the overall. And so in that pattern, I'm using a 1, 0, 0, 1. This is the identity multiplication pattern that you will use. So they're saying, if I take and I invert these numbers, I change them to, and so I flip, and you're flipping them vertically. So you're changing this to 3 and 4, and because those went to Florida, I'm not changing their signs. But when I invert 11 and 1, I am going to Canada, so I am negating both of them. I'm changing their signs. So they're saying that if I take this pattern times this same unknown xy, I should be getting the same thing as doing this one times the answers, which were 7 and 20. Okay. Then the solution, because this is the identity pattern, multiplying by something, it's not changing this. So when I work this side out, I should get the answers for the x and the y. So they're doing, again, row times column, and now they're actually getting the answers. So they jump it to, it comes out 1 and 3, but they don't really show you why that's working. So 3 times row, I only have one column, I don't need the arrow. So 3 times 7 plus negative 11 times 20 should be the top answer. So that's going to be your 20. Why do I feel like that is going to be nowhere near? Did I throw a number out? Did I miss a number? 3. Oh goodness, I wrote 11, not 1. Was the original not 11? Oh, good gravy. 3. Oh, I know what I did wrong. In my 0, 1 pattern, yes, I flipped the 3 and the 4, but the 11 and 1, I don't flip them, I just change their signs. That's what I did wrong. Now it's in the inverse pattern. And the 0, see, it doesn't matter about the change in sign. Okay, so now it should be 3 times 7, negative 1 times 20. That seems a whole lot better. So 21 minus 20 is 1. So their answer for X was 1, and that is what they said, yes. And then this row, so now negative 11 times 7 plus 4 times the 20, so that's negative 77 plus 80, and that is 3. The y should be 3. Yes, that is what they said for their answers for X and Y. Okay, so the explanation took forever to get to what you actually do when you are using matrices to solve for X and Y. Now, I feel like substitution, elimination, or even the original matrix is a whole lot easier than dealing with this, but that's neither here nor there. I'm going to finish it with part B, where it's finding the inverse matrice, and then when we get to example 1, they'll actually have us solve. And there's one other part that was not in their explanation piece that you'll need in order to do it, but I'll get there when I do example 1. So the inverse matrice is, and they go through a long explanation. They have an original with an A, B, C, and D inside it. Then they show you an inverse matrix, which is a whole bunch of fractions. And then they try to explain where they got that from. And they're going back to using this as their basic. And so I feel like their part B in finding the inverse matrice, that their explanation is just wordy at best. I think the key takeaway here is that this is the identity pattern, and let's jump into the specifics in example 1. So it says use matrix algebra to find the X and the Y when we are given 5x plus 8y equals negative 4 and 6x plus 10y equals negative 6. So these are the systems equations, and then we're going to pull off, and so the matrix would be 5, 8, 6, and 10, and we're going to find its inverse, which is going to be flipping the 5 and the 10, so this is going to 10 and 5, and then changing the sign but not changing them to negative 8 and negative 6. So that's the inverse piece. Now here's the extra part. You need to find the original determinant of this one. So 5 times 10 is 50, 6 times 8 is 48, and it's negative, and 50 minus 48 is 2. Okay, so the other thing that is keeping this matrix algebra working is that you need to multiply the reciprocal of this determinant with the inverse. So 2 goes to 1/2. So you're going to multiply 1/2 by this. I'm going to have to flip the page to actually do that. But basically, I'm going to do 1/2 times 10 is 5. That's negative 3. That's negative 4. And that becomes, unfortunately, a fraction 5/2. Okay, so let me jump over here and let's get to that. So it's now 5, negative 3, negative 4, and 5/2 or 2.5. Okay, so we've inversed those, we've changed their signs, we found the determinant, we flipped that over, and we multiplied it, and now we're here. So you are now getting to ask yourself this multiplying with, should be the x, y, should be giving you, oh, the answers from the original equation, -4 and -6. All right, I'm trying to follow what they're actually saying. That was their original times their flip-flopped, their x and y. Now they're getting down to this multiplying, okay, all right, backwards. Multiplying this matrix to get the x and the y, okay, which is ultimately what we want to solve for. So we're doing our row and our column to get our answers for x and y. So 5 times -4 plus -4 times -6. So the x will equal -20 plus 24, so 4. And then our y will be this row, -3 times -4 plus 2.5 times our -6. So 12 minus, whatever that is. Without the calculator, that's a little, just a second. That should be -15, okay. And then 12 minus 15 is -3, so my y is -3, and then technically it's in a coordinate point, but because this is matrices, I'm going to leave it with this, with the x is 4 and the y is -3.